2 o'clock. Hello, everyone. Welcome to the second webinar of our HEART program. I am Stacy Bowe, Training Coordinator for the Smithsonian Cultural Rescue Initiative, and I'm here with Ella Weiner, who is our Training Project Assistant, who is providing technical backup. Thanks so much for joining us today. I'm just checking to see how we're doing. Looks like about 40 of you have logged in, which is terrific. Thanks again. So just to get everyone on the same page, HEART stands for Heritage Emergency and Response Training, which is a week-long program sponsored by the Heritage Emergency National Task Force and hosted by the Smithsonian Cultural Rescue Initiative. Financial support for these webinars is provided by the National Endowment for the Humanities, and we are thrilled to have their support, as well as the Andrew W. Mellon Foundation for the HEART program overall. The goal of HEART, for those of you who this is your first time attending a webinar, just to give you some background information, the goal of HEART is to provide realistic, hands-on training on damage assessment, rapid documentation, emergency evacuation and salvage, rehousing and storage, crisis communication, and team building. We do fit a lot into our week-long program. But since we can't cover everything, this 5-part webinar series builds upon the in-person HEART program, reinforcing concepts covered in the in-person training, and they delve more deeply into topics of interest for cultural heritage responders. Next slide, please, Ella. As you see here, our first HEART program was held last November in Washington, D.C., and we welcome the 25 graduates of that class to this webinar. Hi, guys. Next slide, please. A few weeks ago, we completed HEART Puerto Rico, where we brought the same hands-on training to museum professionals around the territory. We again, 25 graduates from that class as well, and we really hope to continue to work with the ongoing recovery work on the island. And I believe some of those graduates from HEART Puerto Rico are attending the webinar as well. Welcome, everyone. But if you don't fall into either one of those camps, we're very glad that you've come today, because whether or not you've participated in the training, we do think you'll find these webinars interesting and informative, or we at least hope you do. When the series is over, the webinar recordings will be uploaded to HENTEF's website, which is culturalrescue.si.edu/HENTEF. And again, we can post that on our closing slide at the conclusion of today's webinar. Now I'm going to turn it over to Ella to talk about the technical side of things. Thanks, Ella.
Hi everyone, so I'm just monitoring the technical side of what's going on. If you have any issues, please just submit a question through the questions box, or if you're having trouble with the GoToWebinar platform overall, please feel free to send me an email. My email is Weiner, W-E-I-N-E-R-E, at si.edu, and I'll do my best to help make sure everything goes smoothly. Also, throughout the course of the webinar, I'm going to be monitoring the questions you submit. So please, we welcome any and all questions for our panelists as we go through the webinar, and I'll be keeping track of those and posing those questions to him during the webinar and at the end, because where we've set aside some time for some question and answer.
Cool, thanks, Ella. And now I'm pleased to introduce today's instructor, Mr. Nick Artim. Nick is a licensed fire protection engineer that specializes in cultural heritage property protection. He has over 30 years experience and has worked throughout the US, Canada, and Europe. Nick is also a member of the National Fire Protection Association's Cultural Heritage Committee. So very glad that he is speaking with our group today. And without further ado, I turn it over to you, Nick. Thanks so much.
Thank you, Stacy. Just have to get my program here and I'll be all set.
All right.
Okay,
You just need to, yeah, perfect.
there we are. Okay, well, good morning, everybody, or good afternoon, or whatever it is, wherever you are. I'm looking at the list of attendees, and it's a nice cross spectrum from across the country. Um, as was mentioned, I'm a fire protection engineer who specializes in cultural heritage properties based in Middlebury, Vermont. My story is a little bit that in high school I was always fascinated by traditional architecture and history, and a guidance counselor told me that I couldn't make a living at that. I was good in science and math, so therefore I should be an engineer. Well, I became an engineer and still ended up in cultural heritage and historic buildings and proved that guidance counselor wrong. I've had a very good career. This is my first webinar experience. I've done a number of sessions through the years, but this is my first attempt at a webinar. So I'm going to do the absolute best I can not to wreck this too much. But fortunately, Ella is watching out for me. So I'm convinced we're going to be quite fine. Hopefully all of you can hear me well, even those of you who may be sitting back there in the cheap seats, wherever that is. So anyway, we're going to start off with our session on, I call it the philosophy of prior protection for cultural heritage. Uh, I first presented this title to Lori Foley from Federal Emergency Management. And Lori said, you can't go having a title like that of philosophy. It sounds too boring. So she changed a little bit, but I brought the title back. And what it really means, and it's a concept that I've actually learned working in Europe, worked on a number of projects in the UK. And one of my first projects I was involved with, they went around the table and asked for the philosophy of each of our engineering disciplines. And I had no idea what that meant until I heard the first couple of people, other disciplines present this. And it turns out what they really mean is following the idea of having a clear understanding of what the problem is, the clear understanding of what the objectives are, and then the methodology plan to go from understanding of the problem to solving it and reaching the objectives. So while the term gets a little, may not be always well used in North America, it's when it really makes a lot of sense to me. So we're going to go through this. If you have questions, of course, please be sure to ask me. One of the difficulties I find with doing sessions like this, where I can't see the faces of each of you, is that sometimes I'm not quite sure that if I'm getting through clearly, but I'm going to certainly do the best that I can. If you have questions, certainly send them in. I may not respond to them immediately because the answer may be a little further up, but I will do the best I can to get to any questions. Okay, now I actually, this seminar, I started putting it together and had it complete until I remembered a couple of other things. And I had to throw these in here. I live relatively close to the Canadian border, close to Montreal and Ottawa and the wonderful city of Quebec. And I was reminded of this news story from Canadian Broadcasting that came in January of this year. And it shows that fire can happen actually anywhere, in any cultural property. I don't know if how many of you have ever been to Quebec, but there's this beautiful Hotel de Glace, which is actually a snow and ice hotel that they construct every year. And in January, there was a fire in the ice hotel. A blaze broke out in one of the guest rooms. And I love the line from manager Jacques Dubois, is that when I received a phone call, I had to repeat it twice because that there was a fire in the hotel, in an ice hotel. Fortunately, it did not go beyond the room where it started. It was started by a candle lighting some bedding on fire. And as one would expect in a hotel made of ice, it tended to confine the fire. But it did send a lot of smoke throughout the hotel. So it just shows that we, in fact, are not immune to just about any of these cultural heritage properties from fire. Now, in the world of cultural heritage protection, we really have to think of the cross spectrum of emergencies that we may encounter. And we can encounter a broad array of them. Whether, they can be weather related, they can be seismic, they could be transportation related issues. And during, since we think in rather long terms of hundreds of years, sometime during the life of our facility, we will encounter some sort of emergency. Now, it hopefully stays small, it doesn't get big, but it is all, emergencies happen. What we are going to focus in this particular session, however, on is fire. Fire tends to be a good universal hazard. It's one that can impact just about any of us. In Vermont, we don't experience tornadoes, but we do experience other weather issues, and fire is something that occurs in the same way that blizzards don't happen in Southern California, but you could nonetheless experience the fire. Now, I like to start off with something as far as definitions. Now, too often the term emergency and disaster are interchanged, and that's really not quite accurate, at least as I see it in the fire world. An emergency, if we use Webster's definition, is an unforeseen combination of circumstances that require immediate action. A friend of mine who worked for was a security director for a state park agency, then one time gave his definition of a disaster. And a disaster is an emergency we screw up. What that says is that if we have an emergency and it's faced with us, if we react properly through proper planning and then action, we can mitigate and certainly reduce the impact of the emergency so that our property survives for another day and we continue telling the story. Now, a question that often comes up to me is introduction is what's the best fire protection? And that really takes the universal answer of it depends. And it depends, as another colleague of mine one time said, what do you want to have left after the fire? And that takes some good thought. And early on, before you bring in, whether it's somebody to design a protection system or to provide some sort of engineering review or an architect, you really have to have a pretty good understanding of what is important to you and what do you want to have left at the end. Now, since I suspect every one of you is from a cultural property that follows the norm that you have unlimited resources, this may not be an issue, but in fact, the reality is we do often have to prioritize, and so it's a good understanding of where that is. What do we want to have left as far as the building, the contents of the building, the people, and the mission? What it means is this is an objective approach to fire protection, which is different from what we find in most normal commercial type buildings where they're often prescriptive described. Again, what do we want to have left after the building? How important is the building? Is the building important? Sometimes one may have to, on a campus of structures, prioritize. Are there some character defining features of the building that must be safeguarded? And certainly we look at this room and we see very important, very valuable artifacts, but the building is also itself is a valuable artifact. That is a traditional ceiling that actually goes back into, I believe this one was the 16th century, that was reconstructed in this particular space. What about the collections? Are there any that are extremely unique, that are very rare, that would be very difficult to recover from a fire? Are there some that we in fact could write off? These are all questions that need to be asked in advance. You know, are there rare artifacts? How do we store them? Are there special vaults? Again, do we have things such as anthropological or biological specimens that we have to safeguard? And then, of course, it's the mission. This particular wonderful house is Emily Dickinson House in Amherst, Massachusetts. And one of the things, as an engineer, I have to admit, not being heavily into poetry, but when I started working on this particular project, I did find Dickinson's poetry fascinating. And she would describe the room from her, or the view from her room. Well, that particular room is up here in the corner. And so if this building was lost, we can still tell Emily's story, but there is something lost about the view that she would see that is still fairly similar historically from what she encountered in her day. And so when we talk about fire protection, there really are multi-elements or facets to that. The first is risk management, fire prevention. First and foremost, we just really don't want the fire to happen. We do want to go to great lengths to make sure that is the situation, because once a fire does occur, there will be some level of damage. Depending on how we react to it will determine what that level is. Of course, there's life safety. It's the protection of those who, first of all, occupy the building, all of us on the staff, but then those visitors that we bring into the building. There is fire resistance, also known as barriers. It's how the fire can be isolated. That's how we detect and notify that there's a fire underway. Security certainly has an impact on this. They have quite a strong role to play. And then, of course, it's putting the fire out once it has been identified. And then following is recovery. The topic I will not touch on other than very briefly is recovery, because that's actually a much broader topic and one that many of you are much more qualified to discuss than I. However, as an engineer, when I come into a project, I do want to know what some of those capabilities are, because that helps me with the first parts. Now, there are a number of technical standards throughout the US and throughout the world that deal with fire protection. However, they by and large focus primarily on life safety. To be quite honest, many of them, if once everybody's out of the building safely and there's the life safety issue has been resolved, these standards don't necessarily care what happens to the building or the collections. There's a role for them, and you will have to address many of the issues in here. But again, we are looking at objective performance. Fortunately, many of these standards have moved in and put in performance-based sections that do allow some variation. And an example of a performance issue is that on a prescriptive situation, we could say the doors have to be 36 inches wide. On a performance-based, we would say the doors have to be wide enough to get everybody out of the room that will occupy it. As mentioned earlier, I am a member of this National Fire Protection Association Cultural Heritage Committee. NFPA writes in numerous standards for a number of topics, ranging from how to install protection systems to healthcare and power stations and all that. But the two that are relevant to our role are these two: 909, which is the code for protection of cultural resources, museums, libraries, and places of worship and their collections, and then 914, which actually focuses on historic structures. And that particular one becomes quite useful when we're trying to determine how to make a traditional wall assembly or door into a fire protected assembly. Now, I show this picture of this ship, and you might be wondering, well, why would he do that? Well, the fact is, what we are trying to actually achieve in cultural heritage protection is not all that different than what they do on an ocean-going vessel. On a ship, they do everything they can to prevent the accident from happening. But if it does happen, they want to be able to know where it is immediately. They want to be able to isolate it. They want to be able to respond and correct the situation, and they want to keep everybody safe. Because one of the distinct disadvantages that ships have is that there's nobody coming to help and there's no place to run. So it has to be successful. You are often looking at a similar scenario where if you have a fire in whether it's a museum or a library, you again want to do everything you can to prevent the fire from happening. You want to identify one that starts. You want to isolate it. You want to control it, and then you want to recover from it. So let us start going through these various parts. And the first one is fire prevention. Now, quickly summarize, many of you have probably already seen this in some book, whatever. This is what's referred to as the fire triangle. And in the fire triangle, it says, first of all, we have to have something that can burn in order for a fire to occur. Any carbon-based material is viewed as a fuel. Then we have to have some oxygen. We have to have greater than approximately 16 to 17% oxygen. And so since normal atmosphere is about 22%, we have plenty of oxygen to burn. And then we have to have that thing that starts the fire, that hot item. Now there's actually a fourth element, and that's actually the chemical reaction has to be ongoing. This thing here, and I'm going to show this multiple times through the session, this is what's actually referred to as a standard fire growth curve. And if you look at temperatures on the left, these are in degrees Celsius, and then a time, and this is a rather abstract period. It's not any specific amount of time. What you have is you start with a point where the hot object comes in contact with that can burn, and you start the fire process. On a standard accidental fire, we normally will see a long period of time in which the fire increases in intensity, but it's still relatively minor. It's referred to as either a smoldering or an incipient stage. At that point, you can smell the smoke. You may be able to see the initial wisps of smoke, but there's not an active visible flame. We then get to a point where the first flames appear. And then what you'll notice on the curve is a very, very rapid rise in temperature as flames ignite and they start to set adjacent items on fire. And it continues to grow to a very severe stage. It can exceed 1,000 degrees Celsius in a room, which is about 1,800 degrees Fahrenheit, relatively quickly. And then it burns off whatever is in the room, and then the temperature decays. Now, I think as we think about our respective properties, we really want to know the fire's down here. And if we do discover it, we want to bring that curve down quickly and not go to a full, complete loss of the structure or the space. Just quickly on here, and this is again in NFPA, and you can actually access that on their website. This is just a list of common causes of fires in libraries and museums. In most buildings, not cultural property related, the top fire sources are typically electrical and then mechanical systems, heating systems. What we find in the cultural heritage world, it turns out that the largest source are often either an incendiary or a suspicious cause. And there's a variety of factors behind that. They range from somebody who doesn't like you, and it's odd to believe that can happen, but you're often viewed as establishment organizations. And if you want to get to the emotional heart of a community, you set the library on fire or you attack a museum. Sometimes it's an inside job. Sometimes it's used to conceal a theft, but it unfortunately is a top cause. And then if we look at the others, it's things such as cooking equipment, natural causes could be a wildland fire. Exposure means the building next door to you caught fire and it set yours on fire. So these are the typical causes. So as we look at buildings and we think about what we need to do from a fire prevention point of view, well, our efforts need to focus heavily on keeping that hot thing from close proximity to that which can burn. This is an office in a heritage property. This one's up in Alaska. And what's real interesting is that heater is actually right next to a code book, a fire code book. So I guess something was missing there a little bit in the thought process. It's using areas such as mechanical rooms. They often become very useful as storage spaces. Unfortunately, when we put combustible things in there next to that heating elements, it becomes problematic. It is instilling a sense of fire prevention in all of our staff. This particular facility, the group that actually maintains these costumes is very, very aware of the risk that something as simple as an iron can cause and could certainly damage or destroy those costumes. And so they go to great lengths to make sure that that iron is well managed. Again, electrical is a very, very big cause. I think that sign is probably pretty obvious at this point. What we find most often the problem with electrical systems is they're overloaded or they're aged. Especially an issue when we deal with historic buildings where we could have some old cabling that goes way back. There are methodologies to perform electronic or thermal imaging scans of circuitry so that we can actually see hot spots behind walls. And that is an excellent fire prevention tool. As you walk through your building and your staff walks through the building, you know the building better than anybody. And if something doesn't look right, then it may in fact not be right. This particular site, I went through there and the director said, you know, I kept looking at that and it didn't look right to me, but I thought well, I guess it's okay because nothing's happened. We need to be very aware. If you see the situation, then you need to remedy it, whether you have an in-house facility management group or you have an outside contractor, an electrician or a plumber or a mechanical contractor, somebody who can come in and look at these situations. We tend to sometimes create our own hazards. And I suspect probably more than one of you has seen this situation out there. When you have this situation, what it means is you probably need some more circuits wired into this particular location, because then it can be done in a safe manner and keep an overloading condition from occurring. what's happening in this particular location is because you have one plug in the wall and all those wires are connected effectively to one plug as we create an overloaded condition at the point where it plugs. Of course, it is managing our own risks. And what you see in this particular office of this bit of an eccentric professor is there's a computer off to the right. Well, what you don't see is he actually had another one underneath some of these piles of papers, and that computer was getting hot and came pretty close to being a difficult situation. So we have to do a lot of self-managing. It's the conditions that occur on a regular basis. Again, be vigilant to this. Here we have this particular wire. When I looked at this, in fact, one of the conductors was actually bare through, and it was from being pinched in that door. And it was an emergency waiting to occur. Actually, at that point, one could say it was an emergency. It was just prior to a fire. And fortunately, by unplugging and removing that cord and putting in a hard circuit to take care of the appliances that were being served by it, we prevented the emergency from becoming a disaster. Now, as I say, anything that can burn is a fuel, and it should be known that not all fuels are the same. And I use this particular example here. In Vermont, we refer to a fireplace as an air conditioner. And for anybody who's lit a fire in a fireplace, you know that you don't really start off by trying to light that big log, because it'll take a long time and it may not light very easily. So what we do is we put in kindling fuels. We take newspapers, we take small twigs and pieces of wood. Those start burning very easily because there's a lot of surface area. And the surface area is what accelerates the growth of the fire. Once that fire is started, then it starts burning the log, and then we have a significant fire. Again, what we're looking at is if we deal with a situation such as a non-kindling fuel, again, the log, you can have a very long incipient. If we have kindling, we actually start the fire about right here, and it grows quickly. So as we look through our various spaces, the risk can vary. In this particular space, traditional furnishings in a period room, really very little, if any, kindling at all. A fire in here would be a very slow starting and a very slow growing event. This particular space, actually, it would be a similar scenario, a very slow, long growing fire. What's actually was a fire prevention technique used in this space is that all the fabrics, whether they were the cushions on the sofas and on the chairs or the curtains themselves, were actually treated with a fire retardant so that they resist the ignition. And that essentially turned them into non-combustible materials. We get to the common storage rooms, we start to see the hazards build up as we have all these kindling materials. We all know they have to happen sometimes, and so the key there is to, one, try to minimize the amount of this and make sure that if a fire does start in there, it stays isolated in that space. Here, probably not one of the better storage practices I've ever seen of these traditional and historic blueprints. Going back, if we think of the example of newspaper and kindling lighting a fireplace, I think we can envision what that would do. Would be a very, very fast growing fire. The ultimate resolution that actually happened was taking those and putting them into dense paper board boxes or filing cabinets, at which point they were now contained and the hazard went away dramatically. Of course, these wrappings we see in our properties, very important as far as safe transport and storage, but it is actually hardened gasoline. And so we have to be very cautious about where we keep these materials. They can burn very quickly. Flammable liquid cabinets, great idea, but they do have to be closed to be effective. Of course, laboratory environments, we have a number of chemicals that may be used in conservation work, in restoration work. We just have to be very cautious to that as far as how we store them. We need to make sure that these rooms are fairly isolated so that if a fire does start, it remains confined. And of course, there is the arson scenario. What we had here was a situation of a traditional historic dairy barn, and most likely the fire was started from hay and those type of materials that were in the floors, and it spread to the structure and continued on. We have to be aware of temporary situations during construction periods or change of exhibits. I mean, this particular room is actually, when in normal conditions, is a very, very low risk room. but during the setup process for the exhibit, which also then allowed a chance for facilities to come in and add in some new piping and conduit, the hazard was dramatically increased in this building. Of course, special events, Christmas trees. I love Christmas. I love Christmas trees, but sometimes they can be a little bit of a challenge, especially in museums. Doesn't mean we can't use them. We just have to be very cautious as to how well we manage them and take care of them. And then sometimes it's some of the art exhibits itself. I saw this particular one, and it's fascinating to me. This particular museum, it does in fact create quite a risk with the amount of wood there. Some of those wood pallets are often used for fire test purposes, and that certainly is a bit of a problem that I see. It doesn't mean we can't have it. We just have to make sure that the building and the space is properly safeguarded in case anything bad ever happens. Fire prevention efforts means looking for those fire protection elements that we may need in an emergency. It's things such as making sure extinguishers aren't hidden, to make sure that manual alarm stations, which is actually hidden back around the corner here on this particular photo, are available. And it's also making sure that we and our staff understand where these devices are. Again, it's looking for the things that we install to protect our building to make sure they're fine. Here's one more example of walking through this historic building with the director, and he said, that didn't really look right to me either, but I didn't know what to do about it. Well, what to do, this particular smoke detector, is you see it's hanging down by its cables, and in fact, this one was in a trouble condition, which meant it probably wouldn't function properly. When you see things like this, and it does happen, then you need to resolve it, whether it's reporting it again through the facility's chain of command or fire alarm contractor or whomever your specialist is that you have available. The next item is life safety, and I think we all know that's very key. We want to take care of ourselves, we want to take care of our staff, we want to take care of our visitors. They come to our institutions and they expect to be safe. Life safety focuses on making sure that if there is an emergency, whether it is a fire or a weather event or a seismic event, there's good, adequate ways to get out. And there are a number of ways we can use our spaces to safely egress. As staff, as professionals that own and operate these buildings, we need to know where they are ourselves. And it's knowing where maybe there's a point of refuge within our building where one can pass through a set of very hardened doors and enter into a safe compartment. That is commonly used in the healthcare industry where we can't evacuate everybody, but it's very common opportunity in museums and libraries as well. Again, when we see something that doesn't look right, it may in fact not be right. Here we have this exit door that's been blocked by a coat rack. We see this situation too, and this is becomes interesting when one is in the design process. I mean, I can see what happened here is that the architect wanted to, or actually had to maintain a certain corridor width to meet egress standards. Of course, the institution wanted as much storage opportunity as they could. Those rooms to the right are vaults. So then there was only so much room to put both. So that became the width of the vault, became the width of the stair. And then next thing you know, the corridor is blocked with more storage. And so what that has done is impeded the ability to move people safely through that space. And that's a situation to be avoided. Here we see this egress. Again, if something doesn't look right, it may in fact not be. That propane tank that was put to serve that kitchen for special events that's on the lower level, it just happens to be underneath an egress stair. And one could say there might be a risk there. And of course, there's the unique. If you have a unique situation, certainly you're going to have to talk to whether it's the fire or building officials to determine if this, in fact, is an adequate and acceptable egress. And a point on that is that when one is looking at ways to safeguard one's building, use the building and fire officials as stakeholders. I always find that I have the greatest degree of success when I get them involved early on so they understand the problem and we can find a resolution that meets the standards that they're mandated to enforce, but still achieves the objectives that we want to have. Of course, there's always this ongoing debate between security and fire protection people. We want people to get out, security doesn't. And so there are ways to create locked spaces that can open when they need to in the event of an emergency. This is not one of them. Next thing we're going to talk about a little bit is fire resistance. So what this means is that for some reason a fire occurred. We tried to prevent it. We went to great lengths and accidents happen. So fire resistance is the ability to confine that fire to a compartment where it originates. And that will have a great impact on what the recovery ultimately is. And that can vary from the type of occupancy, the type of materials that may be stored. We may be willing to have a large compartment where we have an office environment or maybe a cafeteria or something like that, where it's not terribly difficult to recover. Whereas we want very small compartments if we have rare book vaults or artifact vaults or the like. Fire resistance is achieved by the building itself. And it's those elements that help to isolate a fire or minimize migration of a fire and the products that it produces, whether it's flames, heat, smoke, or gases. And that's achieved by the walls, the ceilings, the floors, the doors, those things that pass through, such as dampers on ducts and the like. Now, if we look at this photo here, and fire guys always like to have pictures of fires. It's just the way we are. You can see here that the fire resisting features of the building didn't do their job. In fact, what was happening in this particular project is a wonderful historic structure that was undergoing a massive renovation, and the contractor took down all the fire resistance features and accidental fire occurs, and this is what the result was. And unfortunately, the structure was lost. Again, going back to our curve, we want to be able to identify how big the fire needs to be. We need to get a grasp of what sort of fire duration we can expect, and then we have fire resistant features of the building so that that duration is not exceeded. It does not exceed the capability of the walls and the ceilings and those elements that isolate. Again, the building is that item that confines our fire. And here we see some buildings. They're highly fire resistant structures. Those are not going to burn down. They're very strong, durable structures. However, there can be somewhat of a misnomer that people would call these a fireproof building, and they are not fireproof buildings because we fill them with things such as furnishings and papers and a number of other items that can burn readily. And so we could have a very severe fire inside of a non-combustible building. And in fact, sometimes they become very difficult fires because these non-combustible buildings, like an oven, will retain the heat. And so those are factors we need to know about. Again, the building elements will do a very fine job, if they're allowed to, of confining the fire, including traditional wood lath with plaster outside. I hear many times from especially fire officials who are not familiar with traditional buildings that the old buildings are dangerous, and that's not at all true. We can make them safe. And in fact, these old plaster walls, they can resist a fire for 30 minutes to upwards of multiple hours. There's been some studies and tests done through the years on traditional or what they call archaic materials and find out these behave very well. However, for them to behave well, we can't have things such as plaster that's broken away and exposing the wood lath. It has to be a solid material. We have to make sure that openings and holes in walls and ceilings are fixed and they are returned back to the condition they were originally. The irony of this particular one is that that red cable is actually fire alarm wire, and the fire alarm contractor was the one who cut this big hole in this barrier. If we go back to our ship example, think about this for a second. Would you want to see a hole like that in the hull of a ship? I think we all know the answer. And so when you see these type of situations, they do in fact need to be remedied. These are things that in our fire prevention walkthrough we will see. This particular case was it's a historic church, And I'm in the room where the blower motor is for the pipe organ, and this door is non-existent that actually extends into the attic. And so one can imagine what would happen if that blower motor, which is a high risk item, catches fire. It should stay isolated in the room where it stays, but in fact it's going to migrate up into the attic of the church. And when a fire gets in an attic of a church, it's a bad scene, and often leads to heavy destruction. So the very simple Fire Prevention Act is to repair that door and put it back to normal and have that compartmentalization. Here, there was a generally good attempt made. In fact, they actually upgraded the fire resistance of this traditional door, but they left where the whole pipes went through, they left these little holes, which is just enough to allow smoke to migrate through and possibly even some flame. We can take traditional materials and make them fire safe. This particular stairway, this is prior to renovating. This building is going to undergo a major renovation, but that door will be upgraded. In this case, I think we're going to use a reproduction of the traditional door, but I've done situations where using some fire-resistant materials, been able to make a door like that into a 30-minute door, as well as all the wall structure around. That was done in this particular case. Actually, the analysis showed that this traditional iron door had a very, very high level of fire resistance, and all we had to do was create a way that it could close automatically in the event of fire, and when the fire alarm goes off, that's what happens. This particular space, actually, it is a museum that was in an old factory, and they did a really nice job of actually taking traditional industrial features and made it work for them. These are actually our rolling fire shutters. We would hardly want those in a aesthetically sensitive institution, but in this case, in this industrial building, it added to the appearance, and it's why it was chosen. And they're designed to close down if the fire alarm activates and create a series of compartments so that we don't get fire migrating between these two spaces. Here, what they did is actually took this traditional glass block and they just added a sprinkler to wet the surface of the glass so that, again, it retains its integrity. Now, sometimes finding that compartment takes a little bit of close examination and creativity. We're obviously not going to close the stairway off. It's a character-defining feature of this building, and we don't want to do that. But by looking at where each level goes and how the corridor arrangements are in the various rooms, invariably we're able to find some place where the compartment can be defined. In a space like this, it actually considers many of the rooms as individual compartments, and the fire resistance was installed to confine a fire to the room and not let it get into the stairway. So that created our compartment. Time to be extremely aware is during construction and renovation, because many of the fire features that we have, especially compartmentalization, may be removed and creates this opportunity for an accidental fire to travel rather quickly. And in some cases, the compartment is just going to be a single element of the whole building. We cannot restrict the size of the space. We're not going to put a firewall down the middle of this church sanctuary. And then we have to look at supplemental protection. And that supplemental protection becomes our fire detection notification and our suppression system. So we'll start off with fire detection notification. And what that is that's the fire alarm portion of the building. And a fire alarm basically consists of a control panel that takes in information from some event that it happens and processes it and determines what to do. The devices in the field may be those that identify smoke or heat. It could be a manually activated device. It could be a sprinkler. It then determines whether it sounds zone notification or the entire building. It can close doors. It can shut fans down. It can call off-site monitoring. It can call security. Of course, it also calls the fire department. The heart of this is a control panel. Now, you don't really need to know much about how these control panels work, but what you do need to be involved with is the terminology used on the control panel. The standard fire alarm panel now is what's referred to as an addressable panel, and that device is monitoring the status of every smoke sensor, heat sensor, sprinkler flow, et cetera, in the field. And when one of those devices reports as abnormal, it then identifies through its memory what that device is and what the action is. They will put out an alphanumeric text that describes what is going on. And the information that comes out in that text is invaluable to helping with the emergency response so that we're able to move people out of harm's way and the emergency responders are able to go and suppress the incident. It's very important that you become involved with the terminology so that it reflects, in fact, what you call these respective spaces in your room and in your structure. I can think of a case. It was a library over in Scotland that I was working on, and there were two elevators, or lifts as they call it, and the fire alarm contractor looked at them and said they were the north and the south lift. Well, one evening there was a fire in a elevator motor room. Came in as the north lift. The Edinburgh Fire Brigade responds. Security meets them at the door and they said, "Where's the fire?" And they said, "We don't have an idea because it's in something called the north lift. We don't have that." Well, it's because the terminology was that they called it the main lift and the wee lift, and the fire was in the wee lift. And so that little bit of terminology issue impacted the ability of the fire brigade to respond as fast as they could have. They did solve the incident before it became a bad situation, but again, it's terminology that is very important. Now the fire alarm system, that control panel, is monitoring those things out in the field throughout the building that identify an abnormality. And those detectors are basically under this category, group of categories. Thermal replicates the sense of touch that we have. Smoke replicates our sense of smell. Flame represents our sense of sight, as does video. Video detectors are relatively new in the field. They actually are done through the security cameras, but can be very, very effective. Again, going back to our curve, when do we want to know about the fire? And that will be somewhat dependent on what's in the space, the type of space, environmental conditions, and the like. Smoke sensors, they identify the fire during this incipient stage. Thermal, not until we get to the point where the temperature is increased enough to trip this device that's looking for a hot event, which is then just prior to the rapid rise. Video detection actually, and some of the more sensitive smoke detection devices can actually identify that fire really early on. Thermal detectors, very common, very stable. Again, the problem with them is they do not react until the room gets hot, at which point there is active flame going on. We really only use them in cultural properties in areas that are subject to sub-freezing conditions because smoke sensors don't work in that condition. Places that are environmentally very dusty or dirty, where a smoke sensor could be impacted. They're sort of the detector of last resort, where we have to know there's a fire going, but the smoke sensors just won't work in that condition. Often, sometimes they're used to initiate fire suppression systems. As in this particular large wooden dome, we actually have a combination, and I'll describe this in a minute, known as a pre-action sprinkler, where what in fact we are doing is identifying, first of all, the heat, which trips the thermal detection, and then as the heat gets a little hotter, it activates the sprinkler, it releases the water. It's designed to avoid an inadvertent discharge, especially below this dome is a very ornate plaster room. What we use most of the time for the cultural protection world is the device that identifies smoke. And here we can, see if we get back to that space. There's a small little smoke sensor up in here. They can be placed to minimize the aesthetic impact. In fact, I've had the pleasure of working for a number of years at Hearst Castle, and they actually have done a fantastic job installing smoke sensors out there and actually putting a gold leaf over the smoke sensor housing so that it does disappear up in there. Again, these are designed to recognize smoke, that fire during that incipient early smoldering stage. There are detectors that can cast a light beam across a large open area, and that light beam, when it's broken by the first elements of smoke, will go into alarm. very well suited for aesthetically sensitive spaces. There are extremely sensitive air sampling smoke detectors that will pick up invisible smoke particles at the earliest stages. The detector has a network of tubes that radiate throughout the protected space and will be able to, again, identify very, very minute smoke particles. They're also very well suited to extremely ornate ceilings where I do not want a device up on that ceiling. I can integrate the detector into a number of architectural features and hide them very well. The fire suppression systems are monitored by the fire alarm system. If we get an activation of a sprinkler or a water mist or a gas agent system, we want to know about that. And so they are monitored, as are potential faults. If a valve is closed, if a wire is broken, if a detector is damaged, the controller can actually identify that and report it as a fault so that we can have it corrected before it prevents its proper operation. And then security cameras also provide a very, very important role in the fire detection aspect of this effort. First of all, as I mentioned earlier, they do have video flame detection. Video smoke detection is now available. And they also have the ability to look into a space to determine conditions. So they actually have become part of a fire protection program. One of the more unique detectors I've ever encountered. This is a multi-purpose detector. It reacts to heat, and it provides something neat to the responding emergency people. Manual fire alarm stations, they're placed there so that if an emergency happens, the alarm can be raised. And then the notification devices are also placed throughout. Notification devices can range from the very simple bell or horn and flashing light to speakers that can be used to broadcast not only a fire message, but also other emergencies. For a long time in the fire protection world, we didn't really like to let others play with our toys. And so fire emergency broadcasts were typically allowed to be only fire. Now the standards have been modified so that we can use that same communication network to broadcast emergencies for weather incidents, seismic, transportation. It gives us a lot more adaptability. And they can be pre-recorded messages followed by picking up a microphone and providing direction. Again, going back to our curve, this is where our video smoke and our air sampling detectors will activate. This is where the rest of our smoke detection devices will activate. This is where video flame and where thermal detectors activate. And just for reference, and we'll get to this next, fire sprinkler systems and water mist systems are actually thermal detectors that then do something as far as addressing the fire. Fire suppression. Once we have identified the fire, we want to do something about it. Now, there are basically four outcomes once the fire happens. First one is it goes out by itself. It lacks the fuel or the oxygen to continue the combustion process. It does happen. It's not something we generally want to rely on, but occasionally it could happen. The fire is extinguished by someone, and that someone could be a person with a fire extinguisher or a glass of water or a bucket of water. Often it really refers to that group known as the fire department who will respond and deal with this problem. It's extinguished by something, and that something can be an automatic sprinkler system, an automatic water mist system, or a gas extinguishing system, or the building burns down. Now, in the cultural property world, we generally do not like the fourth option, and so we'll take that one off. We usually can't rely on the first, and so we have to focus on either a manual or automatic extinguishing. Manual extinguishment, well, the most common tools are those fire extinguishers that are placed throughout the building. The key is to make sure that one understands how to use them. They are very limited in their capability. Generally, if the fire is about much bigger than that, which is about 1 meter high, it's going to exceed the capability of the extinguisher. But if one responds quickly while the fire is in its early stage, then it can be very successful. Generally, we rely on the fire department. And what's really important with the fire department is for them to know your building. And that means inviting them in. Sometimes I know it's very difficult, especially in large urban areas, to get them to come and tour. It actually tends to be easier in many cases in small communities where the volunteer firefighters are always looking for a good evening to get out. So, but as much familiarity that they can have with your facility, the better it will be when that emergency happens. It also means that they understand your chain of command and who will be the key people that they meet with. Often, if you have a professional security force, they will be the people who meet the fire department. And in this particular case, that fire officer awaited the arrival of the security director, who in fact was outside waiting for the fire truck to show up, and did not commit his forces until he had a clear understanding from the security officer of what was going on. The two worked closely and hand in hand. If what is important is that you have the right person to meet the emergency responders. And it has to be the person who, without no pun intended, is the individual who can behave best under fire. You have to have that calmness. I've seen situations where in a museum where the director is that emergency contact and they do a great job. I've seen other directors that just don't handle the pressure very well in emergency and they fall apart. And so suddenly that ensues with some difficulty. If you're not the best person, that's okay. I mean, we all handle emergencies differently, but have that first line person ready to respond. Facility managers often are very good at this. Security directors are often good at this. It may be somebody else. And it's not that you're giving up your command, you're just authorizing them to be the lead person with you closely connected to them. One does have to recognize, though, that in some situations, the fire may grow to a point where it exceeds the capability of the fire department. Once again, here we had compartment failure and the fire became quite severe. And much of the fire department's efforts are actually focused on safeguarding that church next door, referred to as an exposure, because they don't want that one burning, and confining the fire to the building where it starts. As one can imagine, this creates a very bad scene for recovery. The loss was high. It's a very difficult scenario to encounter. Working with the fire department, they can provide information as to some of the challenges that they may encounter. Can they actually get to your building? And if not, what can be done to improve the chances of having good access? What will happen while they are responding? That has an impact on what kind of protection features you will put in it. This particular case is an Adirondack great camp, and one of the difficulties becomes winter, which in the Adirondacks lasts about 11 and a half months. And so you can imagine trying to get a fire truck to this area in the winter. Well, that meant that special provisions were made with this local fire department to be able to access it through snow machines. Now, the other issue is that something puts the fire out. We want to actually respond to the fire faster than the fire can get there, the fire department can get there. And so we do that through automatic suppression systems. We include standard pressure sprinklers, which generally referred to as a fire sprinkler, the water mist sprinkler, which is a newer developed technology, actually came out of the marine industry, the ship industry, where they have to be able to confine a fire and put it out without putting too much water on the fire, and has found good application in the cultural heritage world. And then those systems can come in a wet, dry, pipe, pre-action, deluge arrangement, and I'll describe those in a moment. There are gases, sometimes referred to by the industry as clean agents, not a term that I use. I prefer the gas term. And then there's hybrid systems, which actually are combinations of water and gases. And there aren't too many of those out there, but they do have some unique opportunities. We'll start with the water sprinkler, which is the most common fire suppression tool. It's been around for a long time. We see a discharge here of a standard head, which is about 15 to 20 gallons per minute. Certainly that's a lot of water, but because it's reacting relatively early in the fire process, it is confining the fire and keeping it from spreading to the point where much more water is needed when the fire department shows up with 100 to 500 gallon per minute hoses. Now, one of the things, if you look at that water drop, it's a very, very heavy rain. And the principle of suppression in a sprinkler is to get those things which can burn wet so that they don't burn. And then it also will douse water onto the fire. Again, a lot of water, but they can be quite effective. And generally, most fires are controlled with 2 to 4 of these sprinklers in flow. Again, they've been around a long time, well over 100 years. There's a track record of them that's been proven. They are very effective, and they've been used in a number of spaces, including this particular historic hotel. I know that's an incredibly ugly system, and that's actually going to be resolved with some upcoming renovations. This system was put in the 1930s, and that was the best technology available at the time. A sprinkler is a thermal activated faucet. What happens is when the room gets hot enough, typically above 150, 160 degrees, the thermal element on the sprinkler breaks. It opens up the waterway and allows the water to flow. Sometimes Hollywood shows off this misnomer that if one sprinkler goes off, everyone in the room goes off, and that's not true. They are individual activated. Then they're supplied through a piping network that transports the water from the source to the sprinkler head. There's a set of valves that are in there that can control operation. An important part is actually to become familiar with the valve locations, or whomever in your organization is responsible for emergency action, and to make sure that these locations are clearly defined and the fire department is aware of them. Because once the fire department has responded and they're confident that the fire has been controlled by the suppression system, they will then want to shut the water flow off quickly, and the sooner they can do that, the less the collateral damage from water flow. Again, they're good for most buildings. With care, they can be integrated into a traditional building style very well to minimize aesthetic impact. Again, they're good for most properties out there. Because of their soaking nature, they can take care of some of the dense, heavy fuels quite well. The newer generation of sprinklers is this thing called water mist. And once again, it was designed for the purpose of protecting ships, because on a ship, they have to absolutely be sure they control the fire, and they have to do so without putting so much water that they impact the stability of the vessel. It's used extensively in Europe, extensively in Asia for land-based applications, and its popularity has grown tremendously in the last decade in North America. Now, excuse me, if you look at water mist, what you see in this picture is actually what appears to be a very dense fog, and in fact, that's what it is. Water flow here is about 1 to 2 gallons per minute, which is a tenth of what we have for traditional sprinkler. And the way it works is because it creates so much surface area on the water droplets, and its surface area is what cools the fire, it actually allows a higher rate of heat absorption than a traditional system, because it's taken maybe one droplet and it's broken it up into 10,000 micro droplets. It's a very dense cloud. Very small. I mean, we're talking, one 1/100th of a millimeter. So they're very, very small, and it uses a lot less water. They do not have as many opportunities for application. They're very good in most museum applications. They sometimes become problematic in very large, high spaces, not necessarily a large room, but a high space room, or areas where you may have extremely dense fuels such as storage rooms, large storage rooms. And again, that varies. There's a lot of capability, but it's more specialized. Like a sprinkler, they're a thermal activated bulb, and they have various pumping methods. They have various pressurized water cylinder methods. I actually find a lot of favor with them in rural areas. about 75% of my work is rural. And when I don't have a public water main or a reliable public utility for electricity, I may not be able to work a traditional sprinkler well, and these things work very nicely. From a cultural heritage property point of view, we do not see the level of water saturation on walls, historic building fabric, and we don't see the level of saturation on artifacts. So that makes them quite nice. They are all stainless steel, which means their longevity is there. I've worked on buildings where the walls haven't been opened in 100 to 200 years. And so cutting into that wall fabric is a difficult and expensive and not desirable event. So if we're going to access the wall, we want to make sure that we only do it once for many, many years. This is a water mist protected space, this entrance foyer. The heads are actually color coded and they're up on the ceiling. There's one right there, another one right there. And so they protect this historic entrance foyer. They do, in fact, work with many rare document collections. And what also makes them nice is that they can be integrated in some of these older stacks because the dimension of materials is much lower. They actually perform best the hotter the fire is. And so when we do have these kindling incidents that we have to deal with, they become a very effective opportunity. Good for wet collections, biological specimens and the like, because we don't get the level of water runoff and environmental cleanup that may be necessary with other methods. Again, rural locations, they're really quite good. This is a historic lighthouse district south of Monterey, and it sits up on top of that 300-foot high rock. And I don't have a water supply up there, and I don't have long-term reliable electrical power, so the intent is to put a self-contained nitrogen-powered water mist system up on that rock. Whether it's a standard sprinkler or a water mist sprinkler, they are all in the similar configurations. You have the wet arrangement, which is used in most spaces. It's where the pipes are filled with water, and as soon as that sprinkler breaks, the water is discharged. You have the dry arrangement. One of the misnomers of dry systems is that I've had museum professionals say, well, I don't want water in the pipes in case I physically damage the pipe. I want a dry system. Well, a dry system, all it is the water is not in the piping, and instead we put in compressed air or nitrogen that keeps a valve closed. And once that sprinkler breaks, that nitrogen or air is expelled through the opening of the sprinkler and the valve opens immediately. We use these in areas subject to freezing. So if you're afraid of physical damage to the sprinkler, the standard dry system will not be the answer. It will still give you water, it's just that it may take 30 seconds to get there. The third system is known as pre-action. This is the situation I described a little earlier with that big dome where I need the fire protection, but I need to make sure I don't get an accidental discharge, again, generally due to physical damage. And so in that case, I have a sprinkler system, basically a dry sprinkler system, and then I have a separate thermal detection system which opens up the valve and allows water to flow. So I need two events to happen in order for fire to be controlled. The exception to the situation where when one sprinkler opens, they don't all open is the system where we actually deluge the outside of a building. So, and in this case, this is the Old North Church in Boston. And along the eave of the structure, there is a set of open sprinklers which are designed in case this building over here decides to burn so that it doesn't impact the North Church. It's really intended to be a supplement to the fire department and allow that building wall to stay cool so that the North Church is unharmed. The next type of system are the gaseous agents. Here we see a discharge, and there's a number of them out there. There's the agents known as inerting agents, which are those things that reduce the oxygen content from that 22% down to a point of less than, say, 15 or 16%, where active flame cannot continue. There's the various halocarbons. Halon 1301 was a long-term used gas, which was actually very, very good and is no longer available due to ozone depleting aspects. They tend to actually have more of a chemical interaction and some cooling. Hybrids are basically water and nitrogen systems. The important things is these are intended for special and unique hazards. Limited, they work on combustible liquids, they work on electronics, limited solid combustibles. So it's very important that if you are looking to use this, one is it's a small space, it's one that can be confined because the gas has to stay within the compartment where it's discharged. And you have to be cautious to make sure that the gas that is selected is capable of controlling the fire that's likely to occur. Gas systems, they are contained within pressurized cylinders. There is a detection system similar to what I described earlier that then goes to a dedicated control panel, and that control panel, upon receiving a signal that there's a fire in the space, will discharge the gas into the compartment. Again, they're intended for small, relatively small local application systems. This particular rare book space is a case where that's happened. That is actually a very low fire growth compartment, and the fire is expected to stay small and the gas will do just fine in there. One note of caution is that the discharge of a gas is generally violent. And what I mean by that is we're moving a lot of gas into a compartment in a short period of time, so there can be a strong force at the nozzle. So one has to be very careful about where nozzles are placed relative to artifacts. I actually was at a university art museum some years ago where in fact the gas system discharged because of a fire. It was actually an overheating unit. But when it discharged, it actually blew paintings off of the walls because they weren't secured well. So that's a note of caution. So let's go back to our curve. Okay, what we have is down here at this point with regard to suppression, this is actually where the gases can work because they can be discharged in some cases by smoke detection. The water mist in the sprinkler begins to work right here as flames grow. But what they do at that point is once they activate, this fire growth curve stops going up. It comes back down, and so our fire remains relatively small and our subsequent recovery effort is less. I'll touch on this just briefly. This is a concept that's used in Europe extensively. I know of one case in North America where it's happened, and I can see places for it. This is actually at the British Library built a large storage space up in the Yorkshire area. And this is a very, very high rack storage building. And what they did is they actually came up with this solution. It's a product out of Germany that reduces the oxygen content. It actually generates nitrogen. So the oxygen content is below 15, 16%, where again, a flame cannot sustain itself. And so what they did is they actually reduced the combustibility of the space. Very intriguing idea. I do know of some other applications in the Scandinavian areas. A bit difficult with regard to how it's integrated into a building to make sure that in fact the building can confine the nitrogen. But it is an opportunity that's out there, and I can see some applications, especially for rare document and rare artifact vaults, where this could be a very good solution. Then of course, keep in mind that we can have multiple systems in a building depending on what's there. We can have gas extinguishing systems for some highly rare documents. We can have water mist and others, and we can go for conventional sprinkler. It's okay to mix and match, and sometimes it's necessary. So the final element, recovery. What happens after the fire is done? Well, hopefully we never get to the scene where the destruction was so severe that the building is effectively lost. But in fact, it may not be lost. I mean, it could be a situation where the fire has been stopped. Obviously, the damage is severe, but with the proper professionals and efforts, the building, certain elements of that building could be saved. You do want to, it's always advisable to have an architect available that you can call. It's advisable to have a structural engineer you can call and work with the building and fire officials so that they don't come in and automatically say, just tear that structure down. It's a close working relationship post-fire as well. It's having obviously your full recovery plan And that information would, as an engineer, is invaluable to me, because when I understand what your plan is and what your capabilities are, it helps me design protection methodologies to not exceed that capability that you have. It's having a response plan. It's having places to put artifacts and documents that are out of harm's way. It's where the fire department becomes important again, because they can assist in evacuating some of the more valuable items if they know what they are. And there have been a number of instances in history where the fire department brought out the most valuable while the fire was still actively going on. So then, as we bring this session to a close, we go back to the issue of what's the best fire protection for a cultural heritage property. And the answer is, what do you want to have left after the fire? What are your objectives? You know, what's the problem now? What do you want to ultimately achieve? And you achieve it by knowing where you want to stop the fire and what your capabilities are. You integrate fire prevention, the life safety aspect, fire resistance, fire detection notification, suppression, and then, of course, your recovery plan. Again, it's the ship mentality, but hopefully you can see the correlation between what these people who run these vessels and what those of you who are stakeholders in a very important property have in common. Do we want an emergency? We don't want an emergency, but they happen. Do we want a disaster? I think we know the answer to that is no. We don't really want this kind of situation to occur. Now, interestingly, in this particular site, this is Windsor Castle, when they had a fire. The fire brigade is an outstanding organization. They did a fantastic job of keeping that fire from spreading. But the room where this started, the compartment, was severely damaged. But ultimately, the building was saved and the recovery occurred, and the building stands today in a fine example of what a good recovery effort can be. Again, it's ultimately, these buildings are very important to all of us. These contents are very important to all of us, not just those of us who are stakeholders, but to society. And so we want to make sure that they are lasting, and we do the best we can. And so that brings a close to what I have to say. I think we're getting toward the end of our session, but I certainly have time for questions if they emerge. And I'm going to ask Ella to help me if any questions that may come through.
Yeah, perfect. Thank you so much, Nick. We actually have a question from one of our DC Heart participants who is wondering if you could talk a little bit about oxygen exclusion, especially in the context of human safety.
Okay, the oxygen exclusion, and the one example I showed there is the Wagner system. What they do is they take it down, the oxygen down to they say it's a mid-teens percentage, which fire cannot continue. For the normal, healthy human, it's the equivalent of being up at about the elevation of Rocky Mountain National Park. So you're up there around the 12,000, 14,000 foot range. You'll have difficulty breathing, your respiration will go up, but you can survive in there for a short time period. Obviously, if there's a medical issue, then cardiac or cardiology or respiratory, then it could be more difficult. But you can, in fact, survive. Using the example of the British Library, what they do is they do allow facilities people and some of their what they call their book fetchers, the people who go into this space. And they only need to go in there if there's a malfunction. A book falls off of a conveyor, for example, because it's an automated system. But those people do go through an annual medical certification to make sure they're in fine shape. They're allowed to go in there for a period of, I think, up to 10 minutes. If it's anything longer or anything that's more physically exerting, then they have to actually go in there with a supplemental oxygen supply, similar to what firefighters use as their backpacks. So it's a very limited opportunity, but it does have an application. But there is that extra element of making sure that anybody who enters the space is healthy enough to do that. Now, with extinguishing gases, there's also this aspect. Some of the gases, such as energen, which is actually a composite of various inert gases, is also designed to keep the oxygen level in that 15 to 16%, so you can actually safely evacuate. Carbon dioxide is the dangerous one, and I don't really recommend using that in cultural properties. They use them in a lot of transportation vehicles, mostly marine vehicles, engine rooms, for example. But the problem with carbon dioxide is it takes out all the oxygen and you suffocate. So those are not recommended for cultural property because they're too dangerous. But an Energen can work and allows safely to be in there for a brief time.
Gotcha. Okay, thank you. Stacy, did you have a question?
Yeah, thanks, Nick. Well, well, one, I was curious if that Jiffy Pop was actually a legitimate strategy or if that was just some tongue-in-cheek uh, joke in the museum.
Well, actually, what happens there is, and I've been in this business for 30 years, and one of the things, and I work closely with security people too, and I've had the good fortune or misfortune, I'm not sure what it is, by having some really quirky friends I've come to know through the years. So they keep an eye out for these things, and it was a joke somewhere that put out there, but this friend of mine in the security world said, oh, here's what you guys really need to use. And so it is actually a product of a real strange friend.
Gotcha. Okay. Well, it's the strange friends that make life worth living.
Well,
But maybe
yes, they,
more serious question. And apologies to anyone else who has had this technical glitches while you were speaking, Nick. On the Smithsonian side, we were experiencing some very tiny but um, very disruptive audio blips, and I just wanted to make sure that I re-asked you this. So you talked about fire suppression systems that you've encountered in historic properties. Do you also recommend, or maybe not, that's not the right word, but fire detection systems, the thermal, the video? Have you seen which ones are more prevalent in historic properties or which ones work better for historic properties?
yeah, actually, I always recommend some form of detection.
Hmm.
Suppression is always highly desirable, but in all cases, I recommend detection because the sooner we can identify the emergency is underway, the sooner we can do something about it. And the more sensitive the detection is, the better we can respond to the fire before it becomes a serious, highly destructive condition. What we see commonly used, and again, it does vary. Um, Most buildings, it is some sort of ceiling mounted or wall mounted disc, the smoke detection disc. And smoke is always recommended over thermal. And say the only time you don't use smoke is when it's an area where it's a harsh space or the temperatures goes to sub-freezing conditions. So those spot smoke sensors are probably the most widely used. When I get into areas that are aesthetically sensitive, some of those ceilings I showed, where I run into the possibility of interfering with preservation standards or just aesthetic degradation, then I'll use things such as those air sampling detectors where a very, very small little tube or a hole goes into the room and they can be quite invisible and is able to provide a good level of detection. So the two most common are spot sensors, the standard smoke sensor, and then followed by the air sampling. Uh, that's what I see most often. Video has really taken a big stride forward and is really very interesting. I know large art galleries tend to use video because they're looking down through an open area just as an eye would, as the human eye can. And so they can see long distances in a way that maybe a standard detector can't. And so they're becoming more and more prevalent, and that technology is certainly advancing and will continue to advance.
Okay, great. Thanks.
So we have a question from a participant going back to when you were talking about managing fire and security priorities. She was wondering if there's an example of an institution that you can think of that's successfully balanced these kind of security concerns in terms of theft and fire protection concerns.
Oh yeah, I actually see it in a number of places. Well, I guess we can speak because this is a good thing. We can drop names. Colonial Williamsburg has had a really good long history of taking managing that very well. Uh, National Library Archives of Canada has done a tremendous job through the years. It's actually my oldest client and what the group that put me in business. I actually, the National Gallery has a pretty good reputation. Actually, Smithsonian, you've had people who have worked closely together both on fire and environmental safety and security. So yeah, they're out there. And there's actually an organization, and I'll drop the name on this one. It's the
Uh, yeah.
International Foundation for Cultural Property Protection. Goes by the just use the initials IFCPP.
Mhm.
And if you look at that.org, they're actually a group of security professionals that work very closely, and they do a lot of training of security officers and managers, but also others involved in some aspect of security with regard to finding the balance between fire and security issues in there. So they're out there. Of course, the Smithsonian has periodically has had their cultural property protection sessions, and these people are there as well. So there's groups out there that can help with that.
Okay, great. Let's see. We do have room for one more question, and I do have one myself, but I don't want to usurp any questions that our audience might be coming up with, giving them a little bit more time.
I can answer fast.
Appreciate that. Let's see. Well, all right. I'll quick squeeze mine back in there. Are there any recommendations for because I know it's actually been an unfortunate problem here at the Smithsonian as well. Do you have any recommendations on how staff can prepare themselves, not just for when a fire happens, but for when their sprinkler system may unfortunately malfunction, or may burst not due to a fire, but because of something else that's happened?
So what to do? Well, the first and foremost, and certainly Smithsonian, you have the advantage of a highly professional security force, so they can help respond to it, and a top-notch facility maintenance group. But the important part there is to really understand where the control functions are, and work with your fire department so that if you have the inadvertent incident, whether it's physical damage or a malfunction of a component, that the fire department, one, they will respond anyway, but that you can in fact go to that source of water, that valve, and you can shut that down. It does require some discussion again with the emergency responders, because fire department's always reluctant to just willingly say, sure, shut the sprinkler valve down. But given the nature and the value of these properties, I find them often willing to accept that you respond and take action because you're trying to prevent damage from becoming too severe while they respond. So it's knowing where the control functions are and what to do when you get there, or at least if having a group that you can call to immediately respond. And you're right, they do occasionally fail. It's a very, very rare incident, but they are mechanical devices, and sometimes malfunctions occur.
And also, I guess maybe malfunctions occur, but also sometimes there's, human error involved in that as well. Somebody
Oh, yes.
accidentally put something somewhere that accidentally sets the sensitive the sensors off. So I was just thinking that, like, what happens when that happens?
Well,
But
again, you have an emergency at that point underway, so you have to figure, how do I control this emergency to minimize the impact? And the impact there would be shutting off the water flow. But again, it's a thing that you're going to have to spend time with the uh, whatever the authority is in there to gain approval for that. It's kind of interesting because a lot of times, the fire department doesn't want you to shut it down, but the insurance carrier does, because they
mhm,
want to minimize the damage. So again, the unique aspect of cultural properties, and I find fire and building officials, I mean, they value these places and they don't want damage to be any more than what it has to be. So if they have a group, if they can trust you on this one here and know that you're not going to just shut a valve off, leave it shut, and not call them, they'll generally be pretty adaptable.
Great. Okay. And since that it is now right at 3:30, I guess we will start to conclude today's webinar. Thanks so much, Nick. Very informative webinar. I've been taking actually notes myself about various fire systems. So thanks very much.
My pleasure.
Mhm. So yes, and again, apologies everyone for the Smithsonian. If you experience some audio disconnections, apologies from us. I hope they weren't too disruptive. Um, as we are wrapping up, I just want to say that everyone will be receiving a follow-up webinar survey to your email tomorrow, and it just has a few questions on what you thought of today's presentation, and we really would appreciate if you fill that out because we want to make sure that we are giving you guys the best webinar content possible. So please be on the lookout for that and send us your feedback. So like I said, this was our second Heart webinar. We will be having our third webinar next Tuesday, April 10th. And that one is with Deirdre McCarthy, who is the chief of the Cultural Resource GIS facility within the National Park Service. And the title of her webinar next week is Using GIS and GPS in Heritage Emergency Response and Recovery. And everyone is invited to attend that webinar as well. So we hope to see you then. So thanks again, everybody. And thank you again, Nick, for a webinar. And thanks, Ella, for being on the technical side.
Thanks, Stacey.
All right. Thank you guys. Goodbye.